broken into an infinite dimensional space simulator. This is RinomXE. This is all comments about it. I do a lot of commenting. So, to start this off, how it works to start is you have a viewpoint. That is where the viewer will view at. This is view at dimensions, and it defines where the view plane is in any dimensional space. X, Y, and Z. That defines what is X, what is Y, and what is Z for our three-dimensional space that we use is for viewing any dimensional space. And we have capacities, number of points we can have, and that are not making a new buffer, and number of shapes we can have without making a new buffer. This is JavaScript version, and I will be going through it. So, first thing you want to know is how to add a point. Add point, and put in whatever point. They all have to be the same number of dimensions. So, say this was 1000 dimensional, this has to be 1000 dimensional. And so does this. Next thing you do is add a shape. Something I should say about points, you can enter in per coordinate, like it would be 1, 2, whatever, per each part of the coordinate. Anyway, back to shapes. Shapes, you define them by the points you just entered in their order. So, say you just input shape point 1 and point 2 and point 3, that's a triangle. Then what you do is input 0, 1, and 2 as a shape. That would mean it is now input as a shape. You can have planar polygons, lines, with 2 points, or a point for shapes. It will not work for anything else. Next thing would be set 2D points. This just sets, and so point per each point that you input as 2D on the view plane, or not a number if they cannot find anything. This basically just loops through them all as constants for them and gets 2D points. Let's see how that works up here. So, we have the point, viewpoint, view at point right before, X, Y, Z right before, numbers, that is those constants, round width, sugar round, and precision pattern. These are for things of whether it actually comes to your view or not. How much precision can we consider this with? And index, that is for going through all the points. If we are closer than view at point to viewpoint, which is this numbers 2, and then return a null, which means that we can't find a view for this one. If we are in opposite directions, also return a null. Skip all x, y, z values. You can see that down here too. So we use parametric equation. Viewpoint, the index plus point, the index minus viewpoint, the index. That is how much travel in this dimension we have. Then we have multiplying by that numbers is 2 again, which is viewpoint to view at point, dimension in z, divided by point at z minus viewpoint z. And that's parametric equation for this. And we want to tell, is it equal to view at point of that index? If it is not, return a null because we cannot view this. We are only checking not x, y, or z. And same thing for down here, but since we have determined that we can see this, we just get x and y. We can then do things like offset in 2D. It checks for its null. Reverse x axis. Reverse y-axis, and set draw order is next. How does this work? First of all, we need to know, is this 2 points or more, 2 shapes or more, because if it isn't, well, we're not ordering much. So, checks for sizes, initializations, compare the first to the second that we just got, and set a draw order accordingly. Next, loop through things. With each loop, we are getting shape distance as function of it. What this does is, if this is a shape, if it is in 0, now as far as number of elements, just return this. We input view point, all points 2D, indices, z, something, we do loop through all of these things, and numbers for outputting. We start at end and go to -1 or start. If this index x of points 2D is null, return this, so it's less than anything we can have. Also less than anything we can have. So add the difference between this point z and viewpoint z, and distance of points 2D, it defaults to central area being 0, 0, so just multiply x and y by each other in this for a 2D distance. We then take absolute value of this thing divided by shape, length, and distance over number of things. Same things. So, back to draw order. So, what we do is we set up here our bounds that this could be in. It is what? It is this thing. And it's initialized to correct. That's the third. Well, technically fourth, but this is number 3. It tells us what index x we have currently considered already. It starts at 2, so it would be 0 and 1. We can only input with those. We go until, well, these two equal each other. So what we do, this, and that represents distances and z, the absolute z, and for this, we use draw order and round average of these two things. Just of that, compare them. If first is before or second, then do this. Let's move indices 2, and if they are within one of each other, then move indices 2 to indices 1. Otherwise, move it to sealed on to round. And similar for indices 1, if not, but 4. Once these things are equal, and we have found mostly what index x to use, we finally compare it, and if before, then keep it there. If not, +1. We then loop through from that end index to found number. the space we've created, put current index. Now at this point you might be wondering, what's compare? This is compare. Down here we can see z, and then distance, if z less than, and for first, return true. If z greater than, for first, return false. Since they are equal, consider current distances, which is number 1. And that concludes this video. Thank you for watching. This is a 3 or more dimensional thing. Any number of dimensions. Here is a demo. This one is from a Ruby version. Oh. Well, can't show that now. Thanks for watching. Goodbye.